Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on solubility as an equilibrium process. In our last lesson, we reviewed the terms solubility and solution. We also learned about how temperature affects the solubility of different substances. We learned that the solubility of gases typically decreases with an increase in temperature. We also learned that the solubility of almost all solids increases with added heat. In today's lesson, we will learn how to determine the solubility of substances. Specifically, we will discuss the solubility of table salt and sugar at room temperature. Students, let us begin with salt. Ionic solids, or salts, contain both positive and negative ions. These solids are held together by the strong forces of attraction between the oppositely charged particles. When salt, such as the type we use to season our food, is dissolved in water, the ions that form the solid are released into the solution. They become associated with the polar solvent molecules. Salts generally dissociate into their ions when they are dissolved in water. There are two factors that decide whether an ionic compound will dissolve in water. First, the energy it gives off when its ions interact with water molecules must compensate for the amount of energy required to break the bonds within the solid compound. Second, the energy it gives off when the ions interact with the water molecules must compensate for the energy required to separate the water molecules so that the ions can fit into the solution. Students, let us go through this process step by step. When salt is first added to water at room temperature, it dissolves and dissociates quite rapidly. Once the concentration of these ions becomes large enough, the reverse reaction starts to compete with the forward reaction. When this happens, a decreased amount of sodium and chlorine ions enter the solution. Eventually, the concentration of sodium and chlorine ions within the solution becomes large enough that the rate at which precipitation occurs becomes balanced with the rate at which the sodium chloride dissolves. Once this occurs, the concentration of the sodium and chlorine ions remains constant and the system reaches equilibrium. The amount of salt that must be added to a given volume of solvent to form a saturated solution is called the solubility of the salt. Students, let us do an activity. At which point during the solution process does an unsaturated solution form? And at which point does a solution become saturated? Please discuss your answer with the student sitting next to you.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I am sure you had some interesting discussions with your classmates. When the solution is able to continue dissolving more solute, or sodium chloride in this case, it is an unsaturated solution. When the solution reaches the maximum amount of concentration of ions at a given temperature, which is room temperature in this case, the solution is saturated. It is also at equilibrium. Great work, students. Let us continue with our lesson. Sugars, such as those that we use to sweeten our coffee, tea, and baked goods, are quite different. These sugars are molecular solids. The individual molecules in sugars are held together by relatively weak intermolecular forces. When sugar is dissolved in water, the weak bonds between the individual sucrose molecules are broken. The individual molecules are then released into solution. Energy is needed to break the bonds between the sucrose molecules, as well as between the water molecules, so that the sucrose molecules can be sent into the solution. Sugar is able to dissolve in water because energy is produced when the slightly polar sucrose molecules form bonds with the polar water molecules. These weak bonds that form between the solute and the solvent compensate for the energy that is required to separate the structure of the pure solute and the pure solvent. In fact, this process works so well with sugar and water that up to 1,800 grams of sucrose is able to dissolve in only 1 liter of water. However, like a salt solution, when a sugar solution reaches a saturated stage, the sucrose molecules will cease to separate and enter solution. Any extra sugar that is added after equilibrium has been reached will collect at the bottom. Students, what characteristics of sugar make it readily dissolve in water? Please list them now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. How did you do with this activity? Let us go through the characteristics of sugar that make it readily dissolve in water. Sugar is made up of sucrose molecules. These molecules are held together by forces of attraction that are relatively weak. Therefore, it is easier for these bonds to break than those of other compounds. Sugar is also a polar compound. It easily dissolves in water because when a sucrose molecule breaks away from the crystal of sugar, it immediately gets surrounded by molecules of water. Today, we discussed the solubility of table salt and sugar. We discussed what happens to each compound in a water solution. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.